So what you've been doing is putting a quadratic equation, quadratic function into a computer, and you have been looking at what came out. So here's the shape of the graph. You have been identifying three coordinates at the moment, so those two and then this one using the computer. So in this case, this coordinate would have been -1, 0. This coordinate would have been 5, 0. And this coordinate would have been 2, -9. All right. Now, what we were hoping you would be picking out is that if you take the axis of symmetry, go straight down the middle, the equation of the axis of symmetry is basically going to be the x coordinate of the vertex. So I can see that I've got 2, -9 there, so it's going to be x equals 2 is the equation of the axis. All right. So basically what you're doing is you're making a link between this coordinate and the axis of symmetry. So if you can find the coordinate, you can find the axis of symmetry. But equally, if you can find the axis of symmetry, you can find the coordinate. Right. The next thing they were basically hoping you'd find is, well, if this coordinate here is at 2, because x equals 2, this point here is halfway between those. So -1 to 5 is a difference of 6. What's halfway? Half of 6 is 3. So 6 divided by 2 is 3. So if we go 3 back from 5, we get 2. If we go 3 forwards from -1, we get 2, which is the coordinate. All right. Now, there's something else then. So we're making those links. So we know the axis of symmetry is halfway between those 2 points. The coordinate of the vertex is on the axis of symmetry. See how the thing. So really, what we're looking for now is, well, is there any way of finding those 2 points? And there is. So what I'm going to get you to do now is I'm going to ask you to factorize this piece. How to factorize it? So this has only got 1x squared, so it should be 2 numbers that multiply to make 5 and add to make, remember it's multiplied to make -5, so the brackets must have x plus and x minus. So 2 numbers that multiply to make 5 and add to make 4. Okay, the negative is this, that means the bigger number must be negative. So -5 times 1. That does give me -5. If I do -5 add 1, do I get -5? Yes, you do. So actually, we've got y equals, it's still y equals, but we've got +1 and yes.
Could it does it?
No, sorry, yes, it will always be a whole number. You don't, sometimes you can't factor, that's what we'll have to look at afterwards. Right? But we're looking at the ones that can be factored. Now, do you notice anything about the coordinates of these 2 points? Okay, this point and this point, and then do you notice anything about the factorized?
They're just different, like, one is positive and the other is negative.
But do you notice that the 1 and 5 are the same thing? Yeah? So we've got -1 here, and we've got +1. We've got +5, and we've got -5. Well, it's not just the fact they're switching. Basically, to explain it, do you notice how the y coordinate is 0, both of those? So what we want to do is we actually want to find when x plus 1 times x minus 4 equals 0, because the y equals 0, right? Now, this is what we call, we're going to use the null factor law, which says if two things multiply to make 0, then they must be 0. So basically, x plus 1 has to equal 0, and x minus 5 has to equal 0. Okay. So what add 1 makes 0? -1. What subtract 5 makes 0? Let's think about it more, Luke. What subtract 5 makes 0? 5. X equals 5. So do you notice, like you said, do they just switch? Well, it's because actually, what subtract 5 makes 0? Positive 5, the opposite. So these are the two numbers here, look. These are the ones that actually give you those two numbers. So these two things multiply to make the answer 0. So if you've got two things that multiply to make 0, at least one of those things must be 0. It's the only way you can make it. So null factor, null means 0. So what does that mean for us? Well, if you think about it, if we can find the 2x coordinates there, which we can because we can factorise, well, if we can find those two coordinates, we can then find the axis of symmetry, which means we can find the vertex without having to do the graph. And then what we can do is we can sketch the graph. So x plus 1 multiplied by x minus 5. So for that to equal 0, which is this line here, there's 0, look, 0 and 0. For that times that to equal 0, either x plus 1 has to equal 0, or x minus 5 has to equal 0. How do I make x plus 1 equal 0? What must x be? -1. Because -1 add 1 makes 0. So what minus 5 makes 0? 5. 5 minus 5 makes 0. So x has to be 5. Yes. So it's not just it is opposite, it's there is a reason why it is the opposite. So what we want to be able to do is if I give you an equation, you should be able to find the x-axis intersects the axis of symmetry and then the vertex coordinate.
The axis of symmetry.
The axis of symmetry. That's the line that goes through the middle. That's what you've been doing in your x.
Oh, and
Thing that goes down the middle. Not the y-axis that you've just done. One that goes through the middle.
the middle of the.
The middle of the parabola. This orange one.
Okay.
Yeah? So we can find that. So let's if I give you a question, so these notes will be there if you're still making them, right? So if I said, find the x-axis intercepts, and then the axis of symmetry, and the vertex coordinates of, let's do y equals x squared, let's do minus 3x minus 10. Okay. So that's what we want to be able to do. I guess we will probably have to do this one at the beginning of Nexus. So make sure you've written that down and we'll get on with it next lesson.